All right, hello class and welcome to this supplemental video. We're going to keep this video short, okay? The main purpose of this video is to walk you through the second assignment. Now, obviously today in class we had some technical difficulties and I was not able to explain everything that I needed to. So I'm going to use the first 5 minutes or so to talk about these things, and then we'll talk about the assignment. All right. So if you check the announcements, you'll see that there are three things I need to go over. One of them will be the const expression. One will be the const expression. I think I said the const expression and then the const expression. The const keyword and the const expression keyword, and then we'll also go over the constructor here that you see in the assignment. So if I pull open that assignment 2, and we look at the PDF, and you come down to this thing here called the UML, you'll notice that there is a constructor here that has this int equals 10. All right, it has this int equals 10. We really don't know what that is yet. So I'm going to talk about these three things, and now I'll quickly go over the assignment. So first we're going to start with const. All right, the const keyword. What does that mean? Well, you see it here in the assignment quite a few times, all right? You notice that it's here, and it's here. So what does that mean? So in C++, we have, in all object-oriented programming, we have member functions that are defined in different ways. If anything, this should come up here. And so there's two types of member functions. Member functions can alter the object. And member functions also, don't do that. All right, there's kind of, it's either yes or no. Does this member function alter the object or does it not? All right, so member functions that alter the object are called mutators. All right, that's the term we use. And then what about a member function that does not alter an object? Well, we'll just call it a non-mutator or a const member function. So const member functions cannot alter the object. So when I'm talking about that, let's go ahead and look at our example code from today. I'll probably make a few changes to it real briefly. If you were in class today, you'll notice that we talked about this point2d class. All right. And so if we look in here, we kind of wrote a few functions. We didn't quite get to the static one yet, but we did talk about these two functions here. Now, when we come into main and we look at this stuff, we'll notice that some functions may alter the object. So for example, if I call p1.setXy, and I pass in some values here, setXy is changing p1. What does that mean? Well, when we call setXy on p1, might be a little tiny here, when we call setXy on p1, we'll reference the code that we typed for that. And you'll notice here that this is x and this is y. Both this x and y belong to the point2d object, right? These are the instance variables as we discussed. And setXy is changing them. It's changing them. So here we notice that x and y are being changed. X and y are being changed. And so that means that this is a mutator. This is a mutator function, okay? But there is also functions that do not change the object. For example, this toString function. Notice that x and y are not overwritten anywhere in this function. Excuse me. So this is a non-mutator. This is a const function. And so what const does is it just enforces that idea. Const enforces this idea that they cannot alter the object. So I'll give you just kind of two little code bits here for that. So just for example, I'm going to throw the const on the end of both of these. All right. Now, as I said, this is the only one that should be const. I've said that this one should be const here just in the code. But when we come to the CPP file, you'll notice that we are mutating the object. So if we throw it here in Bobby, you'll notice that the compiler actually will not allow this code to work. And it will tell us exactly what's going on. It will say set xy is declared as constant. And therefore, I should not be able to change these things. So let's take a look here. Well, the first thing I need to do is I need to make sure that I've added constant to the end of these. Don't worry, I'll throw this in the notes. I need to make sure that these are constant here in the implementations file. All right. So here we go. Look at this. It says point 2D set xy const, and it says that x is a read-only object, meaning that when I've declared this function to be constant, I am not allowed to overwrite it. I'm not allowed to overwrite it. So when we say something is const, we're just enforcing the idea that this function should not be changing the object at all in any way. So if we remove this const from this function, you'll notice that we'll get a nice compile. We'll get a nice compile here. Things will work. And everything is as it was. Everything is as it was. Now if I check main here, I didn't save that. I didn't save this, so we didn't see the change here, but that's okay. So let me go ahead and just quickly add that stuff to the notes. Any const member function needs the keyword const after the parameter list in both the header and the definition. All right. So as you can see in the code here, as an example, if we go look at the header, notice that toString is declared as constant. And if we look in the CPP file, you'll notice that constant is also declared here. All right. So that's all const means. Let's look at it in the assignment. It says here that get initial bank amount is constant, meaning it will not alter the object. Get bank amount is also constant. It will not alter the object. Same with play on, and same with yes or no. The object will not be altered. Now, the next thing we're talking about is what's this const expression stuff? That just means that whatever this is not going to be changed. So I'm not going to spend very much time on that. I'm just going to explain to you that that means that this int is not going to be changed at all in any way. All right, it's const basically. This cannot be changed. All right. And lastly, we're going to talk about this constructor here. All right, let's talk about this constructor. Now, this constructor is a bit of a special one. All right, and we're going to call this a constructor with default parameters. Now, a constructor with default parameters doubles as both a default constructor and a parameter constructor. Now, personally, I don't do this very often, though it is present in this assignment. Once again, I will say it, I do not do this very often. If I'm going to have a default constructor and a parameter constructor, I usually split them up. For the purpose of this assignment, though, it actually comes out to be something kind of nice. So it's kind of doubles. It works as both, right? We'll just say works as both a default constructor and a parameter constructor. So I'll kind of give you the idea of that in the assignment. But basically, if the header, say, looks like this, 26, and you'll notice that in the UML here, it says int equals 10. So you actually just declare it like that. And so that's the header, but then in the definition, you're required to give that thing a name, and you're not supposed to give it a default value. So the actual definition of this will be int p, for example. All right, and in here you'll get some code going on. All right, And so what this does is if the default constructor is called, that means no parameters provided. Then this constructor, this param constructor, is called with a default value of 10. All right. And if the parameter constructor is called, meaning that there are params provided, then this param constructor is called with whatever parameter value is passed in. All right, so all this is doing is it's doubling as a parameter and a default constructor. So now let's look at the assignment, all right? And I'm gonna run it a few times for you. I've made this very easy for you guys, okay? I've made it very easy. So the first thing you have to do is you have to open up this 26.h file. Now ignore all of this, you don't need it. I've given it to you there, just leave it. And come on down here and notice what I've told you to do. I say use the UML from the PDF and define a 26 class here in this file. And notice I say you are welcome to put all the function definitions in this class, though I wouldn't recommend it. All right, I wouldn't recommend it. Please just put them in the CPP file. I won't mark you if you do it in this file. Just know that you still have to provide this CPP file to code grade, otherwise you'll probably the make file won't compile. All right, so what I'm saying here is you might as well put the definitions in that CPP file because you have to provide that file anyway. So the first thing you do is basically just come here and copy in that UML. So really all you have to do just to get you started here, it's called 26, that's our class. And then in here, you've probably got your private and you've probably got your public parameters here somewhere. And you'll go ahead and just fill them in. All you have to do is open this up and fill them in. Now, I'll give you an example of this one here. It's the constructor. And so all you have to do is put it there. And that is our constructor. Notice that it's public here. And that's what the plus sign means. The plus means it's public and the minus means it's private. All right. So just copy these in kind of as they are. Now, after you've done all of that, your job is to come into this file and fill in each definition for each constructor or function. So notice I've given you all of the to-dos and I gave you a few examples. Notice I gave you the constructor here. And notice that I already did this part for you. So it should work out pretty easily, all right? You shouldn't have any issues with that, as long as you get this in here as that. All right? And so just read through these and fill them in. Notice down here, I didn't include this, but all you have to do is kind of follow this, this little template that I've given you. I've given you the examples, so you're welcome to just kind of follow this as it is. Really no big deal here. So you just fill them in one by one. I've given you all of these comments, all right? So just go ahead and follow the comments as best you can. You can always ask me questions if you need, but that's really all you have to do. All of the definitions go in this file, and all of the headers go in this file. Now I'm running a little bit longer here than 10 minutes, so let's get to running our code. What do you say? So you don't have to code made for this assignment. You do not have to code main. That's all given to you already. So pretty much all you have to do is run make once you have everything done. And whenever you're ready, you do /main. That's what we've renamed it. And here we are presented with the game. So it's asking you to enter the initial bank amount. Now, where do you find that? Well, just open up main.cpp and see if you can find it. So here's main, And notice here's a default constructor being called. And there's a few things that are being declared here. And then finally here we find this cout statement. Welcome to CS202 game of 26. Notice we're there. And then here it says, go ahead and read in the initial bank amount. So that's what it's waiting for us to do right now. Now, it must be between 10 and 200. Of course, I'll enter in some goofy ones and we get some error messages. But the moment I put in something valid, we're going to be presented with playing a board of playing the game once. So what happens is we select our bank amount of 15, and then we're going to roll the dice 130 times, all right? You'll notice in this 26 assignment, in this class, you'll see that we've got this int matrix here. Notice it's a 13 by 10. Now, if you come in here and look, this is 10 across and it's 13 tall. So that's the matrix. That's the matrix. And you're probably wondering, how do I print this? How do I print all of this? Well, lucky enough for you, I told you that it is provided in this PDF. Just scroll all the way down here, and what do you know? We've got ourselves a nice cout statement. You can just copy this right into your code. Let's just go look at it here. 26.cpp, if you come all the way down to the bottom, notice code show game. Follow the PDF to finish the function. The print stuff is included for you in the PDF. So there it is, right? That is your show game function. So here's how it works, all right? What happens is the player will roll a dice. That's rand. You use the rand function for that. And whatever dice value you roll, in this case, it's 2. It's 2 here. So whatever dice value is rolled, you're then going to roll 130 dice. And for the number of 2s you roll, you're assigned a certain amount of points. So we just quickly go through here. There's 1, 2, 3, 4, 5, so on and so forth. You'll come down here and you'll see that I've probably rolled 21 of them. So within this whole grid, there's actually 21 2s that I've rolled here. There's 21 of them. So what we're going to do now is see how much payout I got. How much payout did I get? So let's go ahead and come up here. And you'll notice that this is the payout. So I rolled 21. This is the point count. I rolled 21. Did I win any points here? It looks like I did not. Looks like I did not. I have to get any of these options to get some payout here. But 21 falls in the other category. So I got no payout. And you'll notice that my output here shows that I've lost. And I'm welcome to play another round. And I'm welcome to keep playing as long as I have a value in my current bank. So if I say yes here, I'll kind of do another roll here. This time I selected 5. I rolled a 5. And how many 5s did I roll? Well, you'll go through here. And you'll probably count 25 total 5s in this grid. So we'll come back and we'll check here. Is this worth any points? No, it's not. So on and so forth. So I can keep playing to see if I win at any point. Notice that my current bank value is going down. And I'm just going to double check. It looks like I haven't won yet. So if I keep playing, I might lose. I might just keep losing. Oh, and it looks like I won something here. So notice that I rolled a 4. And how many 4s did I roll? I rolled 26 of them. There's 26 4s in this grid somewhere. So if I come check the payout, you'll notice that 26 gives me 4 payout. And so what this happens is this payout amount of 4 is going to be added to my current bank. So notice that the last round, my current bank was 4. So then I picked to roll another round. I rolled another round. My current bank was deducted to 3, meaning I only have 3 more rolls left. But then I got a payout amount of 4, and so 3 plus 4 is 7. In some sense, I added it. To my current bank. Now, the hardest function in here is play around, and I've given you a nice step-by-step flow here. and I explained to you exactly what you need to do. For the rest of these functions, you just have to follow what it says in the PDF, and I promise your code will work. All right? These are pretty nice descriptions. I did review them myself. In fact, I coded this assignment myself just by following the instructions. So you'll be able to read these, and you should be able to complete the assignment yourself. All right? Now, your only issue will probably be matching the output on code grade as always, so just get started early so that you have plenty of time to match the outputs. If at any time you have any questions, you're welcome to ask me. I'm always available. Not always, but a lot of time I'm available. And that's about it. So let's go ahead and just exit this game. Let's say, no, I don't want to play another round. And then the main will continue on to do some testing, all right? So you might not understand what's going on here, but you'll notice that after you finish playing, it starts to do a bunch of different things here, in which the instructor who made this assignment is just looking to come up with some, say, winning strategies. All right, so there's just a whole bunch of stuff going on down here, and you'll notice that there's just some winning strategy stuff going on, all right? So there's a lot of code in here, and that's what's happening now. So now that I'm done playing, this is just a bunch of testing stuff to prove that your code works. So for the most part, you can skip over this as long as the output matches, which hopefully it will. Do I want to display the game details? Maybe I'll hit yes, and you'll show all of the game details from that game or whatever happened here. Winning strategy, losing strategy. You know, I tell you to ignore that part. Just focus on the beginning part here. Pretty much once you get this stuff working, the rest of it should work just fine. So once you get all of the functions working and you're able to play the game like I was, the rest of the program should work just fine. Like I said, you're welcome to reach out to me. And the last thing I'll say is if the game is random, how's the output going to match? Well, if you don't seed the random function in C++, if you don't seed it, the output will always be the same. So we're all going to be working with the same random values. Your output will match exactly. Thanks for watching this video. I'll see you guys on Thursday. I hope you have a great night and have fun coding.